Chapter exercise. Question number 6. The thermochemical equation for the combustion of methane is as follows. First of all, please recite the definition. Combustion of methane is the enthalpy change when 1 mole of methane is completely burnt in oxygen under standard conditions. Understand? Which of the following statements concerning the above equation is correct? Combustion of 1 mole of methane consumes 1 mole of oxygen. Obviously, it is wrong. It should be 2 moles. Combustion of 1 mole of methane produces 2 mole of steam. Is it correct? It's wrong, because refer to the equation H2O is in liquid state. Combustion of 1 mole of methane absorbs of heat. Again, it's wrong, not absorb. It should be released because it has a negative value. Therefore, answer obviously is D. Combustion of 1 mole of methane releases of heat. Is correct. Understand? Therefore, the answer is dot. Next, question number 7. Number 7. The reaction between hydrogen and oxygen can be written as follows. Which of the following correctly represent the delta H of the above reaction? Is it equal to the standard enthalpy change of formations of water? Now again, please tell me what is the definition. Standard enthalpy change of formations of water is the enthalpy change when 1 mole of water is formed from its constituent elements in their standard states under standard conditions. Yes, it's exactly the same. So number 1 is correct. Number 2, standard enthalpy change of formations of oxygen. Formations of oxygen should be referred to this equation. Formations of oxygen from its element. Its element is also oxygen. Therefore, obviously, 2 is wrong. Standard enthalpy change of combustion of hydrogen. Combustion of hydrogen, it is the enthalpy change when 1 mole of hydrogen is burnt completely in oxygen under standard conditions. Therefore, they share the same equation. So 3 is also correct. Therefore, the answer is C. Can you follow? Please, please, please. Okay? We call the definition very important. Number 8. Which of the following statements concerning standard enthalpy change is correct? Standard enthalpy change of formations of Cl2. Cl2 is an element. In other words, if I need to write down an equation, you can see that it is correct. Formations of chlorine from its elements is also Cl2. There is no change, so enthalpy change must be equal to 0. Next, combustion of hydrogen. Combustion of hydrogen, heat is released, so it will have a negative sign, not positive. Heat of neutralization is always exothermic. Exothermic, that means must have negative sign. Therefore, the answer is A. Do you understand? Next, question number 9 is about the standard enthalpy change of neutralization between some acids and alkalis. Now, please bear in mind, if we have strong acid neutralized with a strong alkali, the standard enthalpy change of neutralization should be equal to negative 57.3 kilojoule per mole. Okay, here we have the largest magnitude. Do you remember magnitude? In comparing negative number, please tell me you are comparing the magnitude, okay, not simply the number. The magnitude in this situation is the largest, So A and X must be strong. Next, A and Y. Compare these two numbers. The magnitude for the second case is smaller. That means Y must be a weaker alkali than X. Next, B and Y. Compare B and Y and B and Z. Here, this magnitude is smaller than this. That means Y is a weaker alkali than Z. Okay, understand? So the relative strength, X is the strongest, and the next one is Y, understand? And then after that, Y is weaker than Z. Now therefore, look at the solution. For sets 1 and 2, alkali X is stronger than Y. For 2 and 3, both have the same alkali, but acid A and alkali Y, the magnitude is smaller. In other words, acid B is stronger than acid A. And then let's compare these two together. This magnitude is smaller. Therefore, Y or Z alkali Z is stronger than alkali Y. Okay? So we can arrange in this way. X is stronger than Y, and Z is stronger than Y. Okay? That means Y is the weakest. That means the answer must be B or D. The last problem is about X and Z. Which one is stronger? Okay? Alkali X reacts with a weaker acid. Do you remember? A is weaker, but yet has a larger magnitude of this value. Okay? Hence, X should be stronger than alkali Z. Do you understand? This problem is quite complicated because the comparison is not too straightforward.